All right, we are continuing with section 13.1, relative extrema, and we are doing problem number 15. All right, so we've got y equals x to the fourth minus 2x squared. So actually, let's just take the derivative. The derivative is going to be 4x cubed minus 2x. And now we're going to identify the critical values by setting this equal to 0. Let's factor it. Y prime, we're going to factor 2x out of this. We're going to be left with x squared minus 1 equals 0. And factoring further, we're going to be left with x minus 1, x plus 1 equals 0. And so the critical values are then going to be 0, 1, and negative 1. So let's put those on the chart. So then we're going to have the interval between 1 and infinity. The interval between 0 and 1, and the interval between negative 1 and 0, and the interval between negative infinity and negative 1. Now we need to identify if the function is increasing or decreasing, so let's look at the sign of the derivative on either side of the critical values. So we need to look at 2x, x minus 1, and x plus 1. 3 components of the derivative. And that'll help us identify the sign of the derivative, which will help us identify if the interval is increasing or decreasing on either side of the critical values, and then that will help us identify the relative extrema. Okay. So between negative infinity and negative 1, let's plug in negative 2. So negative 2 times 2 is negative 4. So that's going to be a negative there. Negative 2 times negative 2 minus 1 is negative as well. And negative 2 plus 1 is negative as well. So a negative times a negative is positive, times a negative is negative. So thus the derivative is negative on that interval, and thus the function is decreasing between negative infinity and negative 1. Alright, between negative 1 and 0, let's plug in negative 0.5. Negative 0.5 times 2 is going to give us a negative value. Negative 0.5 minus 1 is going to give us a negative value. Negative 0.5 plus 1 is going to give us a positive value. A negative times a positive is positive. So that's the derivative is positive in that interval, and thus the function is increasing on that interval. And because the function is decreasing to the left of negative 1 and increasing to the right of negative 1, negative 1 is going to be a relative minima. Alright, let's look at the interval between 0 and 1. Let's plug in 0.5. 2 times 0.5 is positive. 0.5 minus 1 is negative. 0.5 plus 1 is positive. So we have a positive times a positive. So that's going to give us a negative derivative in that interval between 0 and 1, which means the function is decreasing in that interval. And that means that 0, because to the left of it the function is increasing and to the right of it it's decreasing, 0 is a relative maximum. And finally, between 1 and infinity, let's plug in 2. 2 times 2x is 4. That's positive. 2 minus 1 is positive as well. And 2 plus 1 is positive as well. That means the function has a positive derivative in the interval between 1 and infinity, which means that the function is increasing in that interval And so, because the function is decreasing to the left of 1 and increasing to the right of 1, we have a relative minimum for 1. So we have 2 relative minimums and 1 relative maximum. And we are done with this problem, folks. It only took us 5 minutes and 20 seconds.